start chapter 9, and it's a spin-off from what we were finishing up in chapter 8 with the quadratic equations. Ethan. Okay, so chapter 9, we're talking about graphing. First of all, if you'll remember, quadratic function looks like ax squared plus bx plus c. A, B, and C are all numbers. This is also in standard form. Okay? And from everything we learned the last week out of chapter 8, we learned how to factor those. Tonight we're going to start and learn how to graph these. Okay? Now, there's a few things about the quadratic functions. First of all, when you graph this looks like a parabola. A parabola will look almost like a U-shaped, either up or down. Now, it can also be a little more narrow at the top. It can get pretty wide, okay? But it's going to look like a U-shaped kind of drawing. That's a parabola. Now, if you think about this parabola, we're going to also, within this, we're going to have what we call an axis of symmetry. We used to do symmetry when we were like in kindergarten and first grade. We kind of stopped doing symmetry after we got a little older. But if you remember, symmetry says it's an imaginary line that's somehow drawn in here, that if I was to fold this, it's the same on one side as it is the other. Okay? So right now, you're not going to get a drawing that might look like this. Okay? That's not an axis, that doesn't have an axis of symmetry. Okay? That's not even a parabola. Okay? But within these parabolas, they're going to have stuff that's called an axis of symmetry. Okay? I'm going to erase that. Okay? Within these axes of symmetries and parabolas, we're also going to be talking about minimum and maximum. What is minimum? Okay, the least. So a minimum parabola, the minimum point is going to be one that opens up. I'm going to actually go to a new sheet of paper so we can do this, okay? A minimum, I'm just going, y'all can keep adding, I just went to a new sheet, okay? A minimum is going to be where, when you look at your ax squared plus bx plus c, when you're looking at your standard form, then the a is going to be greater than 0. So this point right here has to be greater than 0. So if it's 1 or higher, it's going to open up. You're going to have a maximum point. Let me do this. So it's going to open up. So it's going to look like this. Okay? Maximum, the A is going to be less than 0. And so he's going to go down. So I'm talking about positive numbers. I'm talking about negative numbers. Okay? Everybody good with that? Okay. We also have what we call a vertex. Who remembers what a vertex is? What do you think a vertex is? A point where two lines. So in this parabola, where do you think a vertex would be? I'm going to have a vertex in reference to where the two lines meet. So where do you think a vertex might be here? It's going to be the top point or the lowest point, okay, where it starts to curve back down on opposite sides, okay? So your vertex, okay? And how some people refer to that as, that's where your axis of symmetry. No, you're fine. Okay, intersects. the parabola. So if I'm talking about a vertex, if that's my parabola, the axis of symmetry, remember, is that imaginary line. So this should be my vertex, and it should be a point higher than the others. I know this kind of looks flatter, okay, but this point would be higher than this point here, this point there, okay, so forth. Okay, I'm not a very good artist drawing these things, okay? All right, questions yet? Okay. To find your axis of symmetry, you have an equation, okay? And that is negative b over 2a. So if I gave you anything like 2x squared plus 3x plus 12, okay? First of all, know that that's a parabola. I'm going to take the opposite of b. So whatever this is, I'm going to take the opposite of it. So that was a positive 3, so that means it's going to be negative 3, correct? Over 2 times a. My a in this was 2. So that's going to look like 2 times 2. So once I solve that, I get negative 3 over 4. So if I had a piece of graph paper, and this was 1, at negative, it's negative 1, at negative 3/4 is going to be my axis of symmetry. So my parabola is somehow going to go through this point right here. Okay? Everybody understand how I found axis of symmetry? Everybody good? Can I scoot ahead?
What did you just explain?
This right here, if you're going to graph it at negative 3/4, this right here is my axis of symmetry. So wherever my parabola might fall, it's going to be the axis of symmetry. That's going to cut it in half, whether it's going up or down. Now, we should know, is it going to open up or down? Based upon my min and my max. A is greater than 0 is going to be my up. So I know my parabola is going to be this way. I now know my axis of symmetry. Okay? Now what I can find out is my vertex. Somebody, y'all have that equation written down right there? Okay, and the axis of symmetry, because I'm going to scoot ahead and I'll need that information. Now to find my vertex, you're going to substitute in the axis of symmetry. I'm going to put it as A period, S period. I'm going to shorten that up as axis of symmetry into your quadratic function. So what I'm going to end up doing is I'm going to take my quadratic function, which was what, 2x squared plus 3x plus 12? Is that what it was? And now I'm going to plug in that axis of symmetry, which was negative 3/4. So everywhere there's an x, I'm going to plug in negative 3/4. And this one didn't come out very clean just because I have a fraction. Okay? But now I can do the math. What is negative 3/4 squared? 9 over 16, and it was positive, right? Because negative times negative is positive. So positive 9 over 16. And I'm not going to do this one yet. Which one? Oh, I'm sorry. That one should be negative. Thank you. Do what now? Right here. This 3 came from here. So all I'm doing is replacing my x's. Then I did my exponents. Now I'm going to go through and multiply. So 18 over 16 plus negative 9 over 4 plus 12.
That one isn't supposed to be. That one is supposed to be negative.
Which one? No, because negative 3/4 times negative 3/4 becomes positive. Okay? Need to get a common denominator, which we're going to say is 16. Actually, let's reduce this. This will reduce down to 9/8. That way I don't have to go quite as high. Get a common denominator. So this is going to look like negative 18/8 plus 96/8. I'm just getting a common denominator between everything. Yes. I got a common denominator of 8, which told me I needed to multiply the bottom by 2. And if I multiply the bottom by 2, I have to multiply the top by 2 because 2/2 is 1. So I'm just making him look different, but it's the same number. Okay? Then I did this one by multiplying it by 8. Okay? Now, what is 9 plus negative 18? Negative 9. What is negative 9 plus 96? 87. 87/8. Now, if I think of this as a point, okay, that point is what? 10 and 7/8. Would you agree if I make that a mixed number? So when I'm looking at my graph, we already said the axis of symmetry was at negative 3/4, right? Here was my negative 1. Here was my negative 3/4. When I plugged in negative 3/4 for x, my y come out as 10 and 7/8, correct? So my parabola would start here, up here somewhere, and we already know it opens up. So he's going to be high up on that graph. Right, this becomes your point now. So you have negative 3/4, because that's what you plugged in for x. The point that comes out is that's your vertex. That's the one point. Now, to find the other points, okay, you can start and substitute in, okay, numbers around the negative 3/4. Okay? I probably don't want to substitute in positive 5, okay, because I'm going to get a big long number, okay? I want to go around negative 3/4. I might use negative 1. I might use 0. Okay, 1's not too bad, okay, but I don't want to use 10. Could you imagine having to do 10? To graph it, he's going to be like way off the page on what I've got right there. I'm saying to find more points on this parabola. Okay? Around, yep, for x. And we're going to do those. We're going to make tables from these tonight. And we're going to do one all the way through, okay? I just wanted to show you your vertex right there. Now, after vertex, I think this was the equation we just had. Can anybody tell me what the y-intercept is? Let me ask a question. If you had a line, 2x plus 4, what's your y-intercept? Come on in. Yeah. What's my y-intercept? 4. How did you know that? It doesn't have the x. So what would I have to plug in for x to make sure that I prove that? If it crosses the y-axis, what's the x value? If this was a point, what's the x value? 0. So anytime I plug in 0, that cancels all my variables out and I'm left with the number. So now let's go back. What's my y-intercept? 12. So my y-intercept as a point looks like 0, 12. So now let's think about the graph that I just did over there a minute ago. Does that make sense? 0, 12 would be on my parabola, right? Okay. Alright, let's work through one completely. And we're going to graph it, and then we'll go from there, okay? Yes. So let's say we have y equals 3x squared plus 6x minus 4. First of all, over here to the side, tell me things you already know. Is it going to open up or down? Up. Why? Because A is greater than 1. So I know it's going to open up.
Wait, where's A?
Remember ax squared plus bx plus c? I'm sorry, x. It should be an x, sorry. Plus c. Here's my A. Because A is greater than 1, it opens up. I'm sorry, greater than 0. It opens up. Okay? Now, let's find the axis of symmetry. So axis of symmetry, I want you to write your equation until you learn it. Negative b over 2a. So I'm going to take the opposite of b, which is positive 6. So that's going to give me a negative 6, correct? And 2 times a was 3. So this looks like negative 6 over positive 6, which looks like negative 1. Correct? Okay, I'm going to jump forward a little bit. Y'all just hang right there. I'm going to pull up a piece of graph paper is what I'm going to do.
We could take one up there.
Okay, so here's my graph paper. And I already said the axis of symmetry was what? Negative 1. So I'm going to use a different color. You might want to use like a colored pencil or something. You might want to do a dotted line. You may want to do something, Ethan, that looks a little different, okay? So I'm going to draw my little line at negative 1.
What color is that?
That's green. Okay? And you might want to just label it AS for axis of symmetry. Okay? Now I'm going to go back. Okay? From my axis of symmetry, I'm going to find my vertex. And I find my vertex by plugging negative 1 in for my equation. So if I had 3x squared plus 6x minus 4, I'm going to plug in the negative 1. So I get 3 times negative 1 plus up squared plus 6 times negative 1 minus 4. What's negative 1 squared?
Positive 1.
Positive 1. So it's 3 times 1 plus 6 times negative 1 minus 4. Go through and multiply, so it's 3 minus 6 minus 4. What's 3 minus 6? And negative 3 minus negative 3 minus 4? Negative 7. So the vertex is negative 1, negative 7. Correct? So if I go back to my graph, here's negative 1, 1, 2, 3, 4, 5, 6, 7. Here's my vertex. You already told me I'm going to open up, so my parabola is going to go this way somehow. I just don't know how wide or how thin yet. So I want to go back to my paper. Okay? Everybody good there? Okay, I'm going to actually scoot in a page. Yes, that equation was 3x squared plus 6x minus 4. That was my equation of the original problem. Is that what you're asking?
No, I want
Right there? Okay. Take a second, copy that down if you don't already have it. And remember, all you're doing right here is substituting in. You're substituting your axis of symmetry for x. That's all you're doing for your vertex. Everybody good? Okay, hurry up.
How's your day been, Miss Miller?
It's okay. Okay, everybody good there? Alright. Now, the next thing I can find is my y-intercept. What's my y-intercept? -4. So that point looks like 0, -4, correct? So let's go to our graph. So 0, -4 is a point, right? My y-intercept. If I plugged a 0 in here and a 0 here, that cancels out, that cancels off, and I'm left with -4. That's where your y-intercept came in. Okay? So once I put it on my graph, there's 0, -4, correct? Now, I know a point on the other side now because of axis of symmetry. If this is my axis of symmetry, if this point is one point across, then I also have a point over here, because it's got to cut it in half. Worst case scenario, you now can draw your parabola. Okay? I would like another point or two, okay, just so we can see where we are. So if we look at a table, and I want to plug in my equation, 3x squared plus 6x minus 4. Okay, I've already used 0 for my x because we already plugged in 0 and we know we got -4 based upon the y-intercept, right? Let's plug in 1. So 3 times 1 squared plus 6 times 1 minus 4. What's 1 squared? 1. 3 times 1 is 6 times 1. So what's 3 plus 6? 9 minus 4. So 1 is going to be at 5. So if I go back to my graph, I don't want to go there. Point 1 is going to be at 5. 1, 2, 3, 4, 5. Again, because of my axis of symmetry, this is 2 points away, so I have a point on the other side 2 points away. It is a skinny thingy. Some you're going to find as fat and wide, and some you're going to find as skinny. Now you can draw your parabola, and I cannot draw that. There's your parabola, and you need the labeling. 3x squared plus 6x minus 4. And there you go.
But how did you get that point on?
This one?
Yeah, that one.
Okay. When I go back, you know how I got 0, -4, right? Well, my next closest point, using a whole number, was 1, right? So I kind of plugged into a table down here at the bottom. Okay, here's my x, there's my equation, and here's my y. So I plugged in 1. So everywhere I saw an x, I plugged in 1, and I did the math, and came out with a 5. So my point was 1, 5. So when I looked at my graph, I put a point on 1, 5. And now, because I know this is 2 away from the axis of symmetry, I know I also have a point 2 this way. So that's where this point comes from. Okay? And there's my graph.
Now, which point was the original point down on the first?
This was your vertex. Okay, that's your vertex. I found it by finding the axis of symmetry and plugging it in and finding that vertex. Then I found the y-intercept. See, he's crossing the y-axis. So that's my y-intercept. Once I knew this one was 1 step away, I also knew I had a point this way 1 step away. Alright? Then I went and said, well, this was 0, so let's put the next point in, which would be 1. And there's my 1. And luckily this one turned out as a whole number. Sometimes you may end up getting a fraction when you plug it in, depending on the problem. Okay, so if it was 2.5 steps away, then over here I'd have 2.5 steps away. Okay? Let's look at another one. I know these are long and lengthy. Okay? I do, but, okay? I don't know. Alright, let's look at I hate doing that one. Hold on, let me change. Because we've already done a 3. Y equals negative 2x squared minus 8x minus 2. Okay? First of all, is it going to open up or down? Y down. Because it's below 0. It's a negative. So it's going to open this way somehow. It's going to open down. Now, I want to find my axis of symmetry. Who can tell me what that equation is? Yep. So if I plug that in, the opposite of B is what? The opposite of B is 8, because this is negative 8, so the opposite of it would be 8 over 2 times A. So what is 2 times A? 2 times negative 2, which is negative 4, and what's 8 divided by negative 4? Negative 2. So on your graph paper, let's go ahead and pull up another sheet of graph paper so we can go ahead and look at him. Yeah. Alright, so 0, negative 2. I'm sorry, negative 2. So here's going to be my axis of symmetry. So I'm going to change that color again so we know he's just the axis of symmetry. Okay? Alright, so now I'm going to go back. How do I find my vertex? Substitute in the axis of symmetry. So I'm going to substitute in negative 2. So that says negative 2 squared minus 8 times negative 2 minus 2. What's negative 2 squared? Negative, okay, it's positive 4. What is positive 4 times negative 2? Negative 8. What is negative 8 times negative 2? Negative 8 times negative 2 is positive 16. Okay? Now what is negative 8 plus 6? Negative 8 plus 16? Let's try that again. Negative 8 plus 16? 8. 8 minus 2? 6. So my point of vertex is negative 2, 6. So on my graph, I can put the point negative 2, 1, 2, 3, 4, 5, 6. Now we already said he's going to open down. Okay? The next point I can find is my intercept point, which is what? Negative 2. So I'm going to put 0, negative 2. So on my graph, I'm going to put in the point 0, negative 2. Now where's another point that I know immediately? So it's going to be 2 over here. Does everybody see that? Now I want to find one more point. To find one more point, I want to go into a table. I'm going to keep scooting that up. So I have my x. I have my equation. Somebody read me the equation real quick. Negative 2x squared minus 8x minus 2. Alright, now if I plug in 0, we know we already get negative 2. because that was up here. Okay, I don't have to do that math again. Let's go to a point around it. I could use -1 or I can use +1. Which do y'all want to do? +1. Alright, so we have -2 times 1 squared minus 8 times 1 minus 2. Do the math. 1 squared is 1. -2 times 1. -8 times 1. -8. What is -2 minus 8? -10, and -10 minus 2? -12. So my point now is 1, -12. Oh, sorry, I went the wrong way. So 1, -12. This is in a group of 10, so 10, 11, 12. I'm going to guess. Okay? Now, after I know this point, I can plug one over here, right? Everybody agree this is 3 away? 1, 2, 3. So I'm going to go 3 this way. 1, 2, 3. There's my point. And there starts my parabola. And I missed that point altogether. Sorry about that. That gives me -2x minus 8x minus 2. I'm sorry, squared. Yes, thank you. Yes, still label it. Okay?
Is this all section, like in chapter 9 about, or?
Different ways to start and graph. And maybe some other things too, but this one really wanted you to basically start a lot with tables. And I'm okay doing all tables, but that means when you get here, you're not doing any of that. You're just plugging in random points. Well, I might have plugged in 3, 4, and 5. Could you imagine what 3, 4, and 5 was going to be? Okay, those are going to be some big negative numbers down low, okay? That's why I like to go ahead and introduce you kind of quickly how to go ahead and find that axis of symmetry, your vertex and your y-intercept, so you can focus on where your graph's going to be. Because you might plug in 5 numbers and they may be way over there somewhere, and if you don't know what the axis of symmetry is, you may have to keep plugging in numbers until you find a curve. And there's no point in doing that. Okay? That axis of symmetry and vertex tells me where it's going to curve. So let me ask a question. If I ask you if this had a minimum point or a maximum point, what are you going to tell me? Is this point, you're going to look at your vertex, is that the highest point or the lowest point in the graph? It's the highest. So this is going to be a max point. And then your maximum point would be what? -2, 1, 2, 3, 4, I'm sorry, is that, yeah, no, -2. 1, 2, 3, 4, 5, 6. -2, 6. That's your max point right there. I'm not going to have any number off this parabola that's going to go any higher than that point right there. Well, there is no minimum point on this one. Why? Because those lines keep going and going and going and going and going forever. Okay? Now, in the past, we had talked about domain and range. Remember, domain is your x values. What can my domain be? Could I ever have a point over here somewhere? -10 something? I can, because this line keeps going, right? He goes on and on and on forever. So he might be -10, 2,547. Alright? I'm not going to ask you to graph it, but I can have any x value. The only thing that's going to be hindered is your range value. The range value, y, has to be less than what? What's this y value? So it has to be less than or equal to 6. I'm never going to have a y value that's 10. I'm never going to be able to plug in an x value and get 10 up here somewhere off of your y. So if you ask for domain and range, domain is always going to be all real numbers. It's always going to be all real numbers. Your range is going to change, and that's going to be based upon this. Now, this was a maximum point, so my y values had to be less than that. So what if you think I had a minimum point, then my y's would have to be greater than. Okay? That's the only thing that max and min is telling you. Okay? Let me kind of look and make sure. To find your, to look back real quick, what was my vertex point?
2,
And what was my max min point? Which is what? The same as the vertex, right? So if any point just plainly they ask you to find the maximum or minimum point, you don't have to graph, okay? But you do have to find your axis of symmetry, know if it opens up or down, and find your vertex, and then you're done. Okay? So you'll kind of start, but then you'll know from there, okay? Alright. Alright, here's your homework.